So hi team. So today we are going to discuss about Raks M Plus and how the IDE works, and also we talk about how to program a simple program to the advanced level programming, and what are the different variants of our application. So we have three variants. One is Python as front end and C++ as backend, and we have another variant which is having purely C++ GUI with both backend and frontend as C++. And we have one more, which is a normal terminal version, which is a CLI version. And right now I'm jumping into the application. So you can see in my screen, this is the application. We have an custom logo, and we have designed this application for demo purpose and to understand, to make people to understand how to do this programming in a high level manner, as well as simplifying the coding experience. So here you can see a RaksMPlus UI with different keys and different buttons, and you have different features in this. So one of that particular feature is we get a ID with highlighting the syntax of the language, and we have here three terminals or three output UIs. So one is an output UI where it will print out the outputs and it will show the timing of the execution, both interpretation and compilation of the program. And we have performance. So performance tab right now you can see. So performance tab, it will show you the performance details of that particular program, and it will also do the iterations. The single program, it will iterate 5 times, and it will give you the best in that particular iteration, and also it will show you the execution time, and what are the compiler and all details in a great manner. And we have this build files. Build files is nothing. It will showcase you that the source where all the examples and source are stored, and we will have some artifacts once we run the program. So where these artifacts are saved, and also it will talk about the compilation process, how it is happens, and what are the things it goes through. So we are jumping into the running a simple program. As you can see here, we have a simple program with just printing a message, and also it does a normal bubble sort in Raks M Plus. And conventional C++, bubble sort, and all other sorting methodology use some algorithm, and we specify that algorithm entirely in the program. But we simplify this bubble sort into simply giving the size of array plus the array, so that we are just making it as a keyword. So just by a keyword, you can sort the things. In all the sorting methodology, we use the same similar methodology, so that the program complexity will be lesser and the execution will be more faster. And I will show the performance also of this different programs going forward. So right now we are running this program. This is a simple program we are trying to run. So as you can see in the output window, it is trying to execute that program as in a .rmp file, and it gives us the interpretation and compilation time, and processing total processing time also it gives, and it also gives us a performance in the sense it will showcase whether this application is having the good or bad rating and all those stuff. And right now you can see the here it used to show the output too, and we are going with the compilation process because this is just a run. So we are going for a compilation. So in compilation, what it does, it will execute in the backend as like in a run, and it also gives you the ASM code, assembly language code for the equivalent program, so that if any developers, like here you can see, when you go through the code, it will pop up and show you what is execution time and whether it is rating I told, good or bad. So it is saying it is good. Actually, we have rating blasting fast, very fast, good, and we have not good. So here we are getting good, and as I mentioned, this is a Celeron, Intel Celeron processor with a workload of themes as well as this application. Due to that, its total time it's little bit high, but comparing to the architecture of the machine, this is comparatively very speed. And I'm giving yes. So here you can get the assembly code for that particular program. So you can see the assembly code. So the people who develop arc level applications like IoT or embedded systems, this assembly language will be much more better for them to specify their registers and locations in a pinpoint manner, so that they can enhance the performance. They can make the device performance much more faster, because directly interpreting into the assembly code. Here I'm closing it, and again we are going for the build native. So it will also compile and it will build the program, and it will, this build will generate 3 files, as you know. One is exe.exe, then one is dot object, like binary, and we have .asm. Asm is the assembly language. So here I'm closing. Okay. So here I'm running that exe which already generated. So here it got executed actually, that exe, and here I'm going with the performance actually. So when you go to performance window, you can see it is in the backend. It is trying to run this particular program 5 times, 5 iterations. So out of this 5 iteration, it will give you the best, as well as it will give you the slowest. So as you can see, and also it gives the average in the sense what will be the average speed of this particular execution. So you can see here fastest it is giving, and slowest it is giving, and the average. And next thing, we are going with the build files. So build files also, I told you, it will create certain files, and you can see the compilation and what are the process it does, and the metrics, performance metrics of each task. And it will also show you the build configuration. Build configuration means we designed this for specifically for x64 arc, and it will show which arc we are running. And another thing, here we are also having, like one more thing in build native, we have one more thing to show. Okay, now if you go to this here, code analysis, one tab we will get. So here you can see it will show us assembly instructions executed how much. So 3, and it will also give what is the architecture we are using. So mine, it is Intel Syntax. We are using an Intel machine, so our architecture is x64 Intel, and calling convention, like which OS kind of, and what are the APIs we are using for this machine. All those things it will showcase. And this is a bit about about the GUI version, Python GUI version of our Raks M Plus. Now we are going with the I will show you examples later. Once we go through all the UI applications, we will come back to and show you one by one the programs. So the next one is we are going with the GUI, C++ GUI. So when you come to this particular program, you can see here, we are printing a small program which is just printing a message, and I'm running it. So in the backend it is running. So you can see it, the tokens generated 15, and the top level statement 1, and time taken 0, 0. And here we are going for performance to see what is the exact execution and interpretation and compilation time. So here you can see the token generated at 15, and the program length 74 characters, and the ASM file it has is 462 bytes. And you can see here interpretation 0.276 millisecond as interpretation, and compilation as 0.012 milliseconds, and total processing time 0.28 millisecond. So here we are, you can see the speed, when we go with a, just in a minute. So here we are going with, you see the speed, like GUI with Python and the GUI with the C++, how much speed difference it has, because here the interpretation, it is taking a little bit time because it is going through some layers as it is a GUI version. But this particular C++ GUI, it is basic terminal or basic UI, so which takes, it's very fast when interpreting and compiling a program with the total execution time. And here we will I will show this program again, the example ones. So here we are next to the next application we are going with, it's a CLI part. So I'm starting the CLI part, and here we can see the build, and I'm going with the RMP CLI. We have this application, so I gave that application, and I'm going with the examples. Under examples, I'm giving a simple program bubble sort. So you make sure it is RMP, and now we are giving the command compile or -C. So you can see it is compiling, CLI part, it is compiling the program. It is giving the performance metrics for millisecond, 160 millisecond, and 165 as total millisecond to execute this program. And also it is creating .asm .asm and .o, and .exe it is missing. It is showing, that is because this particular assembler we have used NASM. So in that assembler, exe packaging is having some dependencies, which is getting error. But if we are creating this with GCC or other assemblers, GCC, or we have CLang, all those stuff, it is working fine. But here we have used NASM, and here you can see the compile time, and it also gives us a build configuration. I told here linker is GCC Ming, but the assembler is NASM x64 Windows. So some dependencies are missing, so that's the reason it is not generating the EXE. But in our other packages, we are actually making the EXE available actually. As you see in the Python version, it is generating the EXE and it is running it. So this is about a bit about the application in wall manner, how we are executing, how we are going through different compilers in different UIs. And we have one more thing to talk about, is the performance comparison. Where currently we are going to compare our programs, RMP program to VS CPP program. So as you know, we are claiming that it is 40% faster than CPP. But when we compile this application, these programs, as in a real-time manner, we are getting more than 40%. It's not just a 40% more. Sometimes it came more than 70, 60%, faster than C++. So on an average manner, we are just claiming it as 40%. So I am opening the performance comparison window. So here you can see a program loaded. So I'm just changing that. So we are going with a simple program first. So here you can see hello world. So we written this program in two codes. One is RMP code, the other one is C++ code. So you can see the syntax also difference. What is the difference? Both languages, and we are going to, we will see the output here actually. Output in the sense, we will see the performance metrics here, but the output will be showing us down. So I'm going to build this application. So it is building both application. So you can see it is ready for execution. So we are executing all the program. So you can see here it is showing as excellent, and also it print the output in below. You can see the output as hello, welcome to RaksMPlus language. This is the enhanced RMP with interaction. So you can see here outputs both, and you can see the RMP speed, execution time, and C++ execution time, and even you can see here in the middle the comparison, and it also gives RMP is 77% faster than C++ in this particular program with this workload. You can see my themes is still running and RMP application is running. So even themes, it's a little bit heavy application. So in a CPU like Intel Celeron, with this particular workload, RMP is much more faster than C++. You can see the difference, major difference in the milliseconds. And if I'm going with a different program, so here we have a simple program like in bubble sort.
Yeah, Flemen, just do one thing. So just wanted to know, can you please show the comparison? For example, if we are loading a RMP file, then it will generate a C++ coding, and then we will have to execute both, and we can compare the both the both that actually.
Yeah, so here in the screen you can see that's what we are doing. So here you can see bubble sort. So this is a bubble sort for RMP code. This is a bubble sort for C++. So the major difference you see here bubble sort we are giving it as a keyword, just the size of array, size and array elements. You can see all the program. Like here we are giving different use cases actually. Basic array sorting, it's just a normal array. Then we have two different size arrays. Then we have large arrays we have. And these are the three methodologies we are using. At the same time, you go with the C++. You see here they are implementing that particular algorithm actually. For that, they are taking a little bit of, code. And obviously, that will make the code much more, larger, and the number of lines will be increasing, and the code characters will be increasing. And here also you can see it is the same thing, whatever we do. But in our Raks M Plus, we do that thing in a single command, wherein this C++, it's first logic need to be done, then it is executed. So we are going to execute this both, and we'll see the difference, what is the speed and things like that. So here execution is ready. You can ready for execution. So execution's build is done. Now we are going to execute it. So you can see here. See in the below process, you can see the basic array it is giving, and the result also sorted result 1 2 3 4 5 6 8, like it is showing in a sorted manner. In a C++ also we can see that it is sorted, and you can see the difference. It is saying that 77.2% it is faster, and this is the time it took for RMP, and it is time for C++. And here the execution, how the execution differs. So here interpretation 128.24 milliseconds, where in C++ the compilation is taking 3816.14. So that major difference you can see in execution also, and the total. So this is what, this is how it is making the programs much more efficient, and also it saves a lot of storage. And at the same time, the execution is much more faster due to the shortage, length of program is very less. The methodology we use for array or sorting is much more efficient than C++. And let me show you the quicksort also. So quicksort also similar manner as in as in our bubble sort, but here we have added a decimal number kind of, just for a difference. So let us see how it is. Here also in C++ also you see a logic. First it go with a logic or algorithm first, then it only printing the thing. So obviously it will take some time for C++. They are comparing with RMP, but RMP within a keyword it will be executed and it will show the output. So you can see here the speed changes to 74.9% faster than C++ in this quicksort actually. and you can see the output also in a result manner, in a correct manner. It is showing the output as in both. And we can also go with a merge sort. So we are going with execute or so now you can see it is also executed. Merge sort is being executed, and you can see the output in an good manner, a good order manner with a arranged manner. And here it is saying a 77.3% faster than C++. And this speed can be increased if our workload, themes workload, if it is not there, if you do this particular same application in different CPU processors, this can vary, and it gives you much more faster in the newer versions of CPU, even in point millisecond or point nanoseconds speed it can show when comparing with the latest CPUs. So this is a bit about, Celeron is a base model, and we are going with this model. It is giving this much faster means it's much more faster in newer versions of CPUs. And in this program also, I will show some examples to how to load, load the examples to the applications. So here we are going with a array sorting methodology, or we will go with a practical array sorting. Okay, practical array sorting. It's a simple program in RMP which uses a bubble sort actually, and it will sort out certain certain real time practical sorting examples. For example, students grade. We have a set of students with the grades, and we need to understand who is the lowest, which is the highest grade of a student. For that purpose, we can use this. And we have a product price comparison, like you have certain products and what is the highest price product in that list. Day-to-day life we are using this kind of examples for programming. So we are using that particular program. We implement here a bubble sort methodology, and we are trying to get the result. And here we can see the temperature analysis, athletic performance, and inventory management. If you have multiple inventories, we are managing how the tags and things like that, and investment portfolios, and it's printing, that particular. And you can we are going to run the program first. So here you can see that it is compiling the program, and it gives you the interpretation and the compilation time. And here we are going to build an so first it will give you the assembly code. So it's generating the assembly code. You can see here below generated assembly code. So it's trying to generating a assembly code for this program. So you can see here it has given you the execution details, and it has also created an exe file. So here you can see the assembly code is decreased, and it also shows you assembly instructions. And now we are going to run this program as an exe. So output here also iteration has been done. Now we are going with the GUI version, the same program we are trying to open under examples. So practical array sorting. So you see the same thing here. You can see. So I'm going to run this program. Let me maximize the screen so that you can see the output. So now you can see it got ran, and it is giving you the correct sorted details about the original grade it is showing, and sorted grade it is showing from low to high, and it is given the highest grade out of it, 94. And the same manner the other product comparison also it is giving, and also it is giving the lowest grade. So you can see it is executing the program, and it is giving the output in a great manner, and you can see the performance, how much time, what are the tokens it has. So you can see it is having around 3721 characters program, and it has a token generator 405, and AST statement 1, and ASM code application, the code file size for 62 bytes. And you can see the interpretation time 1.694 millisecond, and compilation is 0.01 millisecond, total of 1.704 millisecond. So this is you can see here also the output, like a program output, and it shows you the entire output. And I have verified this result multiple times. It is giving the correct sorted array, and it is giving you the assigned programmed output as expected. And this is what we go with, because I show you this practical array, because we need to understand where we can apply this particular Raks M Plus programs and the bubble sort. And you can see here one thing, when you see these programs, you can observe one thing. This Raks M Plus is basically making the program or programming methodology much more simpler, and it is making the sorting methodology is much more simpler, as in like you use a keyword to mention your sort. And we also see the performance here. We saw the difference in the performance, and we saw our different UIs. So overall, Raks M Plus is making the modern language, modern programming language much more efficient, and it can be used for supercomputers programming, and it also can be used for multiple IoT based devices, and it is much more secure. And you can see that it can be also made as encrypted manner for people who works in a critical areas or critical workloads. And the CPU efficiency it shows, like when we go with the base model of Intel Celeron, it's giving this much faster execution when compared with the C and Raks M Plus. So overall, it is an good application, and it makes developers work much more easier, and people can integrate this application much more faster into their IDEs using extensions or plugins. And we can also uh, come up with much more advanced programs which can be used in real time. Further, if the application is much more, going forward, the application is going with a more advanced level, we can go with iterations and class definitions and all other advanced level programming methodologies. So this is about this video today. So we have gone through all the perspective of Raks M Plus, and we have explained, we have learned about how to programming Raks M Plus, and we understand about what are the output and what are the performance metrics we use here. And thanks for everyone for for joining to this today's call and understand about the application.